Hey everybody! So in this video we're going to be talking about Descartes' rule of signs and how you can use that to determine the amount of positive real zeros your polynomial has as solutions and the number of negative real zeros that your polynomial may have. Now this looks like an awful lot, but it's really kind of simple. So the number of positive real zeros is equal to the number of variations in signs of f of x, or your polynomial, or less than that by an even number. So let's talk about what that means. If I look at my polynomial down here, I'm going to count the number of times that my signs change. So here I start positive, and then to go here, my signs changed from negative to positive. So that is one sign change. And then I go from a negative x squared to a positive 2. So that's my second sign change, and then positive 2 to positive 1, so there is no sign change there. That means that if I'm talking about positive real solutions, there are going to be 2 or 0. So there won't be 1 because of this statement right here, less than that by an even number, and that has to do with the characteristics of a polynomial. So I know that 2 of my solutions are going to be positive, or none of my solutions are going to be positive. Now we can do the same thing over here. If I'm talking about your positive real zeros, I start here at positive 1, and then I go to negative 2. That's a change. I go from negative 2 to positive 3. So that's the second sign change. I go from positive 3 to negative 6, so that's going to be my third sign change. I go from negative 6 to negative 4. The signs there did not change. And lastly, I went from negative 4 to 8, so that would have been my fourth sign change. So here, there would be 4 real zeros, 2 real zeros, or no real positive zeros. So remember that when you go down, you're counting by even numbers. Now let's talk about the negative. So if I want the number of negative real zeros, this says the number of negative real zeros is equal to the number of variations, so we're doing the same thing, in signs of f of negative x. So what we need to do is plug in a negative x into our polynomial and then look at our sign variations. So let's do that. If I'm substituting in a negative x, that would be 2 to the negative x third minus negative x squared plus 2 times negative x plus 1. So negative x cubed is negative x cubed, and then negative x cubed times 2 is negative 2x cubed. Negative x squared is positive x squared, but this is a minus, so this will be minus x squared. 2 times negative x is negative 2x, and then plus 1. So now I have substituted in, or excuse me, rather evaluated at negative x. Now I'll count the number of sign changes. So I go from negative to negative, no sign change, negative to negative, no sign change, this negative 2 to positive 1. So there is going to be 1 negative root here. Now if I were doing the same thing with my second example, again, I would have to plug in a negative x here and then evaluate my sign changes. So that would be negative x to the 5th minus 2 times negative x to the 4th plus 3 times negative x to the 3rd minus 6 times negative x squared minus 4 times negative x, and this is plus 8. Just did make it, almost ran out of room. Okay, so negative x to the 5th is still going to give me negative x to the 5th. Negative x to the 4th is a positive x to the 4th, but this is being multiplied by negative 2. So this is minus 2x to the 4th. Negative x cubed is a negative x cubed, And then this positive times that negative would make that minus 3x cubed. Negative x squared is going to be positive x squared, but that's being multiplied by negative 6. Negative 4 and negative x is a positive 4x, and then I have my positive 8. So we'll try to make that a little bit neater. There we go. Not much better, but a little bit better. Now we're going to look at the sign variations here. So this was negative to negative, none to negative, no, negative. Okay, right here. So there is only going to be one negative solution here. And that's pretty much it. That's how you determine the number of positive real zeros and the number of negative real zeros. I hope you found this video helpful. If you have any questions, please be sure to leave them in the comments.